Okay, so we're working today on chapter 5. And so I'm going to go over to paper and just see where we stand in this. If what I wanted to do was remind you what the sections had. The first section in chapter 5 was about finding the rate. And when you find the rate, you're expecting the two numbers to be similar quantities. So what we're going to do, for instance, if you had 15 minutes compared to 60 minutes, that would be a rate. And if there's a word involved, you would expect it to cancel so that you can work with these two numbers. It turns out 15 and 60 reduces. You could do it in 2 steps or 1. It turns out 15 times 4 is 60. If you double this, it's 30, and then double that again, it's 60. So this becomes 1 and 4. So the rate in this particular case is 1 to 4. And so I just wanted to remind you, if somehow it turned out this was the problem, 30 divided by 10, you would want to reduce it. And so the 2 zeros at the end can be canceled because you're dividing by 10. This is a shortcut, but it works. So in the past, you might have said, well, that's 3. But when we're talking about a rate, they'll probably say in the instructions, we really want a fraction. So simple reduced fraction. And so with rate, you would want to make it 3 over 1, 3 to 1. Now, in the second section, they had ratio. And in this particular case, the two things that are being compared may not be the same unit. So for instance, if we had 60 miles compared to 2 hours, miles and hours will never cancel, so don't even try it. But you can reduce this. And so in this particular case, if they asked for the ratio in miles per hour, remember this was the instruction, miles per hour. The word per is divide. That means miles is on top, hours is on bottom if you have to make a decision about it. And so then what you do is simplify this the best you can. So this could be, it doesn't have to be a fraction like this. It could be 30 miles per hour. I reduced it. Or you've probably seen it like that, miles per hour. And so that's what you're looking for in that case. The words are part of the answer, right? It's not just 30 what? Miles per hour. And so that was what that was about. Now,
Can you write it 30 over 1?
I don't think you have to on ratio. I think you can just leave it 30.
Right.
You could, I mean, it's possible. I mean, if you wrote it like that, that would make it a fraction. But typically this can just be reduced to the simplest form. And then you're interested in this. What is that? And so I think we'll see it. If anybody has trouble with deciding which way to go, show me that problem or copy it down and we can go over it. So rate and ratio are very similar. We're trying to simplify it down. And if need be, there will be instructions when it's a ratio. And so you follow that exactly. This is not worthless. This is exactly what you need to do. And so you look carefully for that. They did have a quick section on this. 16 equals 2 times x. They had a whole section about this. And I don't think this is a big deal because I think it's fairly obvious. This is a little equation. An equation basically has equal signs and something on either side, left and right. And so your goal was just to say, okay, can I get the x? And because x is multiplied by 2, and they even emphasized it with a dot, although truthfully, if they ever wrote it like that, it's still multiply, because when you have a number and a letter standing for a number, it's assumed multiply. But in this particular section, they seem to put that raised dot in there to help you remember what to do. And so the opposite of multiply would be divide. And you do it to the left side and you do it to the right side exactly the same. And so the 2 divided by 2 is 1. So this is 1x, typically written as just plain x, but it's really 1x. And then over here, it's whatever it happens to be. It happens to be 8. So they had a whole section about that, but I think once you get it, there's no big deal about that. And sometimes the x or the variable, the letter, is on the left and sometimes it's on the right, but that's where the action is. The goal is to get the letter by itself. And so that will be the goal when we solve equations. Can you just find out what the x is? Well, I know what 2x is, but I don't really care about that. I want to know what x is. And so that's why you try to pull off these numbers until you get it x equals whatever. Now, the last section, or that we did on Monday, had to do with what happens if you have a proportion. And so I'm going to let's see. Now, it may be obvious what the answer is, but I just use this example because many times it isn't obvious. This is 8/10. This will be 4/5. And so you might have figured that out already. But this is a proportion. And so it's a simple fraction equal a simple fraction. And so when you get it in this form, you multiply this diagonal, and then you set it equal to the other diagonal. So that 10 times x equals, and don't forget the equals, 5 times 8. Now, this was a mess. This is better. And so what I can do is say, well, 5 times 8 is 40. So I'm going to just say 40 because that would be easier. This is the same exact problem. I want x alone. I don't care for 10x. I care for x. And so I remove the 10 by doing the opposite operation, and the opposite of multiply is divide. So the 10s cancel down to 1. 10/10 is 1. 1x is x. And in this case, as far as I'm concerned, answer is 4. So when you get an answer, the x belonged here. And so if this makes sense and checks, notice 4 times 10 is 40. 5 times 8 is 40. That's what happens when you have equals. You have a true proportion, and that's what happens. Okay? So when they set these up for you and it's all ready to go, then it's pretty easy just to cross multiply. The problem becomes in the next section where you're responsible for setting it up. So what I'm going to do is read you a couple of problems. But this skill of working with proportions is so useful in so many different things. And so your first job will be, do you see it as a proportion? Because the minute you see it as a proportion, then you know, oh my gosh, I'm going to set it up something like that. Now, how do we get this set up correctly? So here's our first problem. A woman drives this many miles, 270 miles in 6 hours. Okay. If she continues at the same rate, listen to the word rate, how far will she go in 10 hours? Now, here's one way. So I wrote that down because I was just sort of taking notes because I knew this mattered. And then if I took some more notes, I would say, well, how many miles in 10 hours? Now, I took my notes intentionally so that you'll understand what makes a good setup. This set of notes actually is ready, almost ready to make a proportion. And here's what I could do. It was miles in 6 hours. How many miles in 10 hours? And so literally, I can turn this into a correct proportion. And so without so many words, it would be 270 over X equals 6 over 10. Now this was miles, but the hours in this particular case are going to be gone. And so we're going to be left with miles. But see the notes, because I was consistent about, I said miles for hours, miles for hours, this will work. And so what I would then do is go back to the previous section or whatever and complete it. So once this is set up properly, 270 times 10, 270 times 10 equals, don't forget it, X times 6, which we would write in algebra 6 times X. When you multiply by 10, the decimal moves over 1. So 270, the decimal is here, multiplying by 10 is 1 decimal place. So that's 2700 equals 6X. It gets easier as you go down the road. So at this point, all we would have to do is divide by 6. Okay. So this is 1X, and then the answer appears here. So if you can do this in your head or do it out like this or whatever you have to do, 6 into 27 is 4. I'm hoping this will divide out nicely. Oh, there it is. 7 take away 4 is 3. Bring down that first 0. 6 into 30 is 5.
50.
And then 6 into that 0 is there. So this is 450. If you have a shaky feeling, and I almost always know when I make a mistake, don't ask me how I do it, but you probably have these sense sometimes, well, it doesn't seem right. Well, clearly that means that the number right here was 540. So if you check this times that, and this one times that, or you could put your 540 here, this was a little bit simpler. This one times that, and this one times that, it will be perfectly the same. Or something went wrong with your division or whatever. Okay? How's that? Here's the deal, and this is what makes word problems annoying for some people. There are literally 8 ways to set this up. 8. 4 of them are correct. Ha! What does that mean? That means that there's 4 ways to set it up incorrectly. And so the trick with these problems, in the first case I showed you, I just took notes, and remember it was 270 miles, 6 hours. How many miles in 10 hours? That was what was given. So this part here is the X. You literally could have set it up a different way. In other words, that first sentence, 270 for 6 hours, could have been written over here. Because these two go together. And so they could have been written in the same fraction. If you'd set it up like that, which is totally fine, the only thing you have left to do is put the 10 hours somewhere. Now the 10 hours belongs on the bottom. So the interesting, although when we solve this, we do this cross multiplying, when we set it up, it's like this matches that, this matches that. So it's set up vertically and horizontally. So miles to hours, this will be miles. And this will be hours. So it's really strict about that. Do you see what I'm saying? It's not diagonal matching. The setup itself, miles to hours, miles to hours. And so this is another legitimate way. And this, of course, is the missing number. So this is X. What I want you to see is when we proceed to do it, we have the exact same problem. So the first way, this is a correct setup. So 270 times 10, that first diagonal is 2,700 equals. This is the second diagonal, 6 times X. That's the same exact problem as before. This is one of the good setups because I did it with that strict structure. And so then you would just divide by 6 and divide by 6. And I think it was what, 450 was the answer. Okay. So the whole thing about this is I think it helps to label the different numbers so that you make them match. So I have miles here and straight across miles here. I have hours here and straight across I have hours. I want you to see the original, the way I did it the first time. The other thing, the way I did it the first time is I had miles top on the left, and this would be miles, miles to miles, hours to hours. This was a match. This will be a match. It's not that hard to get these set up right, but you want to take your time and be satisfied that it's set up. Because obviously when you start to multiply and everything, if you have something out of position, it's not going to work. So let me try another one. So they have different examples. Here's one about a baseball player. So the baseball player gets 8 hits in 18 games. Okay, I'm just reading out of this what I have. If he continues at the same rate, how many hits in 45 games? So that would be how many hits in 45 games. The truth of the matter is, if you took notes straight off of the problem, you can make this your proportion, and it will be hits to hits, games to games, 8 hits went with 18 games. There is no problem. This is half of the problem. And so if I'm looking at your work, you're going to get half credit for just laying out the problem correctly. Because in some cases, as we go further and further with math, or we use a calculator or something, if you don't set it up correctly, all the calculators in the world will not help you. You know what I'm saying? You have to have the correct problem to begin with. And so we had an English problem that had to be translated into math. Now this is ready to fly. And so I'm going to take the 2-word games out of that. The X will be in hits. So it's 8 to X equals 18 to 45. So that's a simple version. Some people can't stand the mess, and that's okay. I understand that. And so then you write it simply. So in this case, I would go 8 times 45. So that's 45 times 8, 0, carry a 4, 32, 36. So 8 times that is 360, unless I'm too tired. And then this times this is X times 18, which would be 18 times X. Ah, I like it. X is over here. I have to ditch the 18 by dividing. I will write divide by 18, divide by 18. There's no issue here. This is going to cancel nice. So this is X, and 18 into 36 goes twice, and 18 into 0, and that's your answer. And it was in hits, if you recall from the way we set it up. So the variation of 8 different ways basically means that these two could have been switched, these two could have been switched, so, and still it would have worked out perfectly. The 8 hits and the 18 games could have been on the same fraction. It really doesn't matter as long as you develop a true way to set this up, and then it should work. Any questions at this point? Here's a problem. This example is almost like chemistry, and I know some of you may take a science course somewhere down the road. And so here's what it looks like. A solution that contains 4 millimeters, and I'm going to abbreviate, 4 millimeters of alcohol and 20 millimeters of water. So that's the first sentence. So what they've done is taken the alcohol and diluted it with water in that proportion, okay, that ratio. Then it says, if another solution is going to have the same ratio, but must contain 25, it was milliliters, I'm sorry, milliliters, I missed it. It's going to have 25 milliliters of water. Question, how much alcohol will it contain? Okay, I'm sorry, I saw that as millimeters and it's milliliters because it's liquid. So 4 milliliters alcohol contained 20 milliliters of water. So that was, it was diluted down like that. How much alcohol for 25 milliliters? Well, if you want, you can make your proportion that way. 4 is to X as 20 is to 25. Okay, the answer will be here when we're done. It will be how many milliliters alcohol. And so we go ahead. And so that's as good as any setup. if you want to set it up another way where this is on top and this is below it, then you just have to make your match, but we're good. 4 times 25 is 100. X times 20 is written as 20x. We do our little divide thing. So the 20s cancel. Now, the thing about zeros, I have 2 zeros here and 1 0 here. I can't cancel out 2 zeros because I only have 1 here, but I can cancel 1 and 1. But you probably figured out this. This is 2 into 10 is actually 5. So the answer based on the original problem would be 5 milliliters alcohol. So in chemistry, and when you're mixing things together, you need to get the proportions right. And so it's a math problem. And so when they have a container of alcohol, it won't be exactly 4, it will be a whole big container. And so you pour off 4 milliliters. Same is true with water. Water doesn't come in 20 milliliter containers. So you pour off 20. And so that's how you make correct mixtures. Now, I once had a student that was a photographer, and they actually developed their pictures, and they had to get the proportions right. Anybody know anything about that? Well, does that make sense? The same would be true with paint. When they mix paint, they have to get the proportions right or your colors don't match. Right? Have you ever thought of that? They're getting the proportions right so that it will definitely match. Now, I want to go back. I want to talk to you about this, and I almost hate to say it, but I'm going to do it anyway. This problem was not that hard to do. The numbers weren't that bad. But the truth of the matter is, this side of the equation was 20 over 25. It was possible to reduce that at the very beginning. Now, you may not want to do that, but in some cases you might. So what I want you to do is forget the other side and just say, well, 5 goes into 24, 5 goes into 5. When this is reduced, I think it's pretty clear this is going to be 5. Or if you carried it through, 4 times 5 is 20 equals x times 4, which is 4x. I'm sorry, 4x. And so when you do your dividing, x is 5. Now, I hesitate to show you that this is a legitimate thing to do, because then people start saying, well, I'll cancel anything I want, because they're remembering when we had the multiplication and you would cancel this number with that number. If you ever do that by mistake, the mistake is always the fact that you didn't put the equals there. You didn't put anything there usually. And so when you don't cancel from this side to that side with an equals, it's basically a block. But you are allowed to cancel one side by itself. And that actually worked. And so, for instance, I just bring it up, and you may not want to do that. It may just be too, you're too likely to make a mistake with that, but it actually is correct. It would work. So let's see. Okay, here's another example. Map reading. Of course, now with technology, this is really not an issue anymore, but I'm still going to show you the problem. On the map, 1 inch on the map corresponds to 95 miles. Okay, 1 inch on the map. This is a paper map, 95 miles. If two cities are 4.5 inches apart, what is their actual distance? Obviously in miles. Okay, so you would just Google it, they'd tell you how many miles it would be, and you wouldn't have to be doing this. Nevertheless, it's an example of the scale on the map is smaller than the actual distance, because if you only had to go 4.5 inches, you'd be there pretty darn quick, right? So the question is, we could just set this up. This goes with that, this goes with that, this will be in miles. And so we can ignore that. So this is basically 1 times x. 1 times x is basically x. The answer appears here, 4.5 times 95. Number 7. I just happen to have a book with answers. So I'm just going to read it right off. How's that? So that's the missing number. It's 400. I don't know how long that would take you. 400 miles, a good bit. How long? What do you think?
Good.
Good. Okay. Here's the thing about chickens. Ready for chickens. So it says the farmer knows for every 50 eggs that the chickens will lay, only 45 are marketable, so they can sell them. So some might be damaged or something not right. And so 45 are good compared to the 50 that you had. So this farmer has a lot of chickens. So he says, if his chickens lay 1,000 eggs in a week, how many of them will be marketable? So these were eggs that were laid, right? This was the number that how many was marketable. So now this farmer has a lot of chickens. So it's 1,000 eggs. How many of them will be marketable? So there you go, equals, there you go. Okay. So obviously it's going to be a number under 1,000, but fairly close to 1,000, I would say. And so let's pull this down a little bit and get rid of some of this mess. So I'm going to start by taking off those zeros because they're not doing a darn thing. And if I felt like it, I could take 5 over 100 and reduce it. What's the advantage of doing that? The advantage is I'm working with smaller numbers. But I don't think this is going to be a bad problem. So I'm going to just take a pair of zeros out like I just did and just multiply 5 times x is 5x. I notice this is going to work out good. This is 100 times 45. This is 4,500.
Plus 100.
Okay. So I took the zeros out. So I'm only, what's left is only 100. So that's 45 times 100 is 4,500. If I'd left them on, I would have extra zeros here, but the only thing left to do is divide by 5. So 5 into 45 is 9 with 2 zeros.
900.
900. So, is that right?
Yes.
Yeah. So that's a still pretty good. Was that just for a day? Let me look. Oh, that was a week. That was a week's worth of eggs, when I look at the problem. So we can sell 900 of them. The other ones, I think we're gonna make some souffle, or scrambled eggs. What do you think? Here's another one. And this has to do with manufacturing. So it says of every 17 parts that this company manufactures, only one of them will be defective. So they make 17, and typically in the past, one of those 17 would be defective. Now, this is just on average, but still it helps to figure things, what's going to happen. How many parts were manufactured if the machine had 8 defective? Now, I don't put the 8 over here because this is total parts. The 8 defective, and here's my advantage of writing down the word, the 8 defective goes under this. This would be X. Okay, so I copied it down just the way they said, 17 parts, but one would be defective. How many parts was what the question was, if there were 8 defective. Notice I had to match this to start with. And if somebody has a correct match, even if it goes wrong, I'm going to look for giving you half credit because this is worth everything right now. Let's see, let's finish this problem. I think 17 times 8.
136.
How much?
136.
136 equals X times 1 would be X. Okay. I've taken a couple of courses in to deal with mathematics and manufacturing, and it has to do with quality control. So for instance, when they have a day where they expect so many parts to be defective, on average, based on what's happened in the past. Now, let's say on average, there's 15 defective parts per day. They actually have somebody that's paying attention to this. And when it turns out that at the end of the day or somewhere during the day, they're having a number that's quite different from this, what should they do? Well, they shouldn't ignore it. They should actually stop the machine and correct it because something's going wrong, and machines have to be corrected and, fixed regularly. But you don't want to just keep making bad parts. You see what I'm saying? And so literally this knowing how many defective parts on average, basically then you can say, well, wait a minute, what's too many? Oh my gosh, it's noon and I already have 15 defective parts. You don't want to just keep going and going and then have to throw the whole lot out, the whole day's work. You want to stop it, fix it, and go on. Does this make sense?
Yeah, because they do it in print shops.
That's exactly. This is quality control. There actually are people that are hired to do this one job. And it is, I don't know if some of you might have to take statistics. You have to pay attention to what's happening normally, and that's what's happening today, and have the nerve to stop it. So I once had somebody that was doing, she was a teacher in statistics, and she was being consultant for a company. And so they had to bring in all these trucks full of cement. Okay? If the proportions aren't correct, then the cement won't harden correctly. And so then it will go bad. Well, it turned out nobody was there that day, and she happened to be stopping by the company. She realized, this was a good story, she realized that the proportions were off. And she had to tell those people with the cement trucks to go home. And she did it. And the thing is, you can't let that happen, because you know how these things, where a mistake is made in a building, sometimes the building collapses. Sometimes there's a major problem. You can't play games with these things. In construction, you have to do it right within a certain, maybe a little bit off might hurt. And statistics actually kind of helps you see how much is too much.
Yeah.
Right? Okay. Okay. So anyway, does this make sense? So, we're thinking about what's needed in mathematics. How does it get used? Well, somebody's paying attention, right? And that's what we're interested in. So I just wanted you to anyway, I took courses, and so that was pretty interesting. So okay, let's do one more. Any question about this? I think it's fairly reasonable how to set these up, but don't rush through this process. In other words, set it up, but then make sure that everything is lined up the way it should. It may or may not give it to you in the exact order you need it, but you have to make that match. Notice how this matches that. This will match that. This will match that. The matching is horizontal and vertical. The solution is diagonal, and don't get the two confused. What I want to do is show you something in the next section. Let me see if I can find it. This is something I actually did with students. And let's see if I can get closer. The height of the tree, okay? So I'm going to draw this for you as soon as, this is in the next section, which we don't do, but now I've known people that were really good arborists and they could climb that tree and be totally happy person, but maybe they don't want to. Do you know what I'm saying? So maybe we could rely on mathematics. So what I'm going to show you with a picture is the shadow created by the man, which is standing right here, is actually proportional to the tree and its shadow, because the sun is coming down at that same angle. So I'm going to draw this for you on paper so that you can actually see the numbers. So here's the paper. So here's the person. So this is the person. And they're 6 feet tall. And the shadow is 4 feet. Okay, so the person is 6 feet tall. Somebody could easily measure the length of their shadow, right? Now, at the exact same time of day, there's this big, huge tree. Okay. Now, this shadow can also be measured because it's same time of day. You measure the shadow. What we really want to know is how tall is the tree? and we don't feel like climbing. What do you say? Can this be set up? Let me suggest. So this will be the man on this side. So it's 6 feet high, 4-foot shadow. Can anybody suggest what goes here and what goes here? I'm gonna bring back the picture.
Feet,
What is that?
feet.
It's gonna be feet,
Oh, okay, I gotcha.
but the number they gave us was the shadow, and the shadow was 38 feet. It has to go here.
Oh,
Because what we want, we know the height of the man. We want the height of the tree. Let me come back to this. We know the height of the man and it has shadow. We want the height of the tree. This was the height of the tree compared to the 38 shadow. Let's see how tall this tree was. Ready? Okay, so 6 is to 4 as x is to 38. Okay, so I just made it so we just in numbers. So 6 times 38, 48, carry a 4, 16, I'm sorry, 18, 22. And then when I go this direction, equals 4x, I divide by 4, I divide by 4. Cancel, cancel, x equals 4 into this is 557. 4 into this is 5, 2 left over, 4 into 28 is 7. That tree is 57 feet tall. Did you want to climb it? Anybody? I have a giant sequoia in the backyard. I always wondered about how tall it is. It's pretty tall. And I could probably do this experiment, but I did it once with students when I was teaching in Maine. We just went out into a field and tried it. Found somebody was 6 feet tall. We just did it like that. Does that make sense? So this is useful. See, all kinds of things get used this way, like surveying and stuff, where you do the mathematics instead of measuring every last inch of that tree.
yeah.
Does it make sense to you? Yeah.
A similar one, Eratosthenes, measure the circumference of the earth.
Yeah. Yeah, I mean, we really want this. So anyway, that's where that's at. This was in the section that we didn't cover, but I think it's so interesting. It's the same exact thing. Whereas the height of the person compared to the shadow, the height of the tree compared to the tree shadow. And so that is correctly set up. When you do the crisscross diagonal multiplication, we're all set. So that actually is chapter 5. So is anybody have questions about some of the homework that's been done? Stop this.